The visionary CEO of Honda has introduced an exciting new innovation, a flying car. This groundbreaking vehicle combines advanced technology, stylish design, and Honda's trusted engineering to bring us closer to a future once imagined only in science fiction. Building on its previous successes, Honda is now focusing on sustainability and electric vehicle development, with a strong emphasis on electric vertical takeoff and landing (eVTOL) technology, essentially flying cars. In 2021, Honda announced plans to develop eVTOL technology, marking a shift from traditional automotive manufacturing to advanced aerial mobility solutions and reaffirming its commitment to clean and efficient air travel. The Honda eVTOL features a unique hybrid power system combining a gas turbine generator and electric motors. This setup allows for longer operational ranges of approximately 400 kilometers, about 249 miles, ideal for intercity travel. This is a significant improvement over competitors that typically rely solely on battery power, which is usually limited to around 100 kilometers, about 62 miles. Honda integrates its expertise in aero engine development and Formula One technology into the eVTOL's hybrid system. The gas turbine generator operates at ultra-high revolutions per minute, drawing on F1 technology for improved efficiency and performance. This turbine runs at tens of thousands of revolutions per minute, much higher than traditional hybrid engines, providing a power density over 10 times greater than typical hybrids. The hybrid system works in a series configuration where the gas turbine generates electricity to power the electric motors that drive the propellers. During takeoff and landing, high power is needed, so the energy management system uses both the gas turbine and battery power to provide the thrust required for vertical takeoff and landing. This dual-source approach ensures the eVTOL performs optimally when needed most. Once the Honda eVTOL reaches cruising altitude, it primarily uses electric motors powered by the gas turbine, which also recharges the batteries. This system ensures efficient energy use, as the turbine operates at peak efficiency and generates extra electricity stored for later. Honda's energy management system is designed to minimize operational costs and environmental impact, significantly reducing fuel consumption compared to traditional aviation. Its ability to regenerate energy during flight also lowers costs and reduces the carbon footprint. The eVTOL is equipped with 8 lifting propellers that provide lift during takeoff and landing. This multi-rotor setup ensures redundancy, which enhances safety and allows for smaller rotor diameters. The smaller rotors produce less noise, making the aircraft quieter during critical phases like takeoff and landing, reducing its environmental impact on urban areas. For forward flight, the eVTOL uses 2 pusher propellers at the rear. These propellers generate thrust once the aircraft transitions from vertical ascent to horizontal cruising. Separating the functions of the propellers optimizes their performance in each phase of flight, improving overall efficiency. The lift plus cruise configuration reduces aerodynamic drag compared to traditional rotorcraft designs. By optimizing the shape and positioning of the propellers, Honda minimizes resistance during forward flight, which is key to extending the eVTOL's range of 400 kilometers, approximately 249 miles, on a single charge. Safety is enhanced by the use of 8 lifting propellers, offering redundancy. If one or more rotors fail, the remaining ones can compensate to ensure safe flight. This feature is particularly important in urban areas where reliability is crucial. The distributed lift also improves stability during both vertical ascent and horizontal cruising, reducing the risk of uncontrolled descent or loss of control, a concern with single-rotor helicopters. The eVTOL's fuselage is made from carbon fiber reinforced polymer, CFRP composites, which provide a high strength-to-weight ratio essential for optimal flight performance. Compared to aluminum, carbon fiber reduces the aircraft's weight by about 10 to 15%, enhancing fuel efficiency and range. The composites are strong yet lightweight, maintaining structural integrity while improving overall performance. The smooth surface of the carbon fiber in the Honda eVTOL contributes to a 10% reduction in drag compared to traditional materials, significantly improving cruise speed and flight efficiency. Additionally, the carbon fiber composites resist corrosion and fatigue, ensuring long-term durability, reducing maintenance costs, and enhancing the overall safety of the aircraft throughout its lifespan. The fuselage employs an innovative manufacturing technique that integrates 2 types of structural designs, honeycomb sandwich panels and stiffened panels, into a cohesive structure. This approach minimizes joints, enhancing structural integrity and simplifying production. The nose and tail sections feature honeycomb cord sandwich structures that offer strength while keeping weight to a minimum. This design is particularly effective for achieving smooth airflow around the aircraft, further improving aerodynamic performance. The eVTOL is equipped with a distinctive tandem wing design featuring 2 wings, a shorter front wing and a longer rear wing. This configuration optimizes lift during various phases of flight, including takeoff, landing, and cruising, while maintaining stability at higher speeds. The tandem design ensures a more even distribution of aerodynamic forces, enhancing performance across different flight conditions. The addition of winglets at the tips of the wings further enhances aerodynamic efficiency by reducing induced drag. Winglets minimize vortex formation at the wingtips, improving the lift-to-drag ratio and boosting fuel efficiency and speed. The aerodynamic benefits of the wings and winglets combined are essential for the eVTOL's high performance. During vertical takeoff, the larger surface area of the rear wing contributes to enhanced lift, facilitating a smooth ascent. In cruise mode, the aerodynamic properties of both wings work together to maintain stability and efficiency at higher speeds. The aircraft is designed to accommodate 1 pilot and 4 passengers, along with their luggage, making it ideal for small group travel. The interior design focuses on passenger comfort, with larger windows to offer expansive views during flight. Towards the end of 2024, the FAA granted Honda Research Institute an exemption, allowing demonstration flights of its eVTOL prototype, designated as the R&D Subscale Model Test Vehicle N241RX. The exemption, valid through October 2026, allows Honda to test various performance and safety characteristics of the aircraft. This approval marks a significant step from conceptual design to practical testing, providing Honda the opportunity to collect real-world data essential for refining the design. Honda's eVTOL development benefits from its experience in previous aircraft certifications, particularly the HAE 420 HondaJet program, which will help streamline the design and certification process. The knowledge gained in aerodynamics, safety protocols, and regulatory compliance will accelerate the path to commercial viability for the eVTOL. With FAA approval in hand for its subscale prototype, Honda is poised to conduct demonstration flights, focusing on key aspects such as stability, control, and efficiency during takeoff, hover, and cruise phases. Despite Honda's advances, the eVTOL market is growing increasingly competitive, with several companies vying to dominate urban air mobility. Joby Aviation, a key competitor, is making substantial progress toward commercializing air taxi services. Joby's performance in the second quarter of 2024 showed a net loss of $123 million, but it has $825 million in cash and short-term investments, positioning it well for the costly stages of certification and production ramp-up. This strong liquidity gives Joby a competitive edge, allowing the company to sustain its operations as it moves forward with its expansion plans. With a market capitalization of around $3.48 billion, Joby is seeing significant investor interest in the growing eVTOL sector. The company is focusing on diverse revenue streams, such as direct sales, partnerships, and operational services, to boost long-term profitability. A major element of Joby's strategy is securing FAA certification, with the company about 37% through Stage 4 of the 5-stage certification process. Joby expects to receive its type certificate by late 2025, a critical milestone for both regulatory approval and market confidence. The company is also enhancing its offerings with a hydrogen electric air taxi and integrating autonomy technology via a partnership with X-Wing. These innovations underscore Joby's leadership in sustainable aviation. Joby has ramped up its manufacturing capabilities, recently rolling out its third production prototype from its California facility. By the end of 2024, Joby aims to produce 1 aircraft per month, supporting its transition to commercial operations. The company has also expanded its production capacity with new facilities in Ohio. A key milestone for Joby came with the delivery of its first eVTOL to the U.S. Air Force under a $131 million contract, highlighting its ability to meet stringent military standards. Beyond domestic markets, Joby is actively pursuing international expansion, seeking certification in Australia and partnering with Mukamala Aviation, a subsidiary of Saudi Aramco, to introduce its aircraft to the Saudi Arabian market. These strategic partnerships will drive demand and facilitate growth in global markets. Collaborations with major industry players like Uber and Delta Airlines are also key to Joby's strategy, enhancing its market presence and providing access to established networks that can significantly speed up the commercialization process and infrastructure development. Archer Aviation Inc., another significant competitor in the eVTOL market, is focused on revolutionizing urban air mobility with its innovative Midnight aircraft. Archer has made notable strides in financial stability, certification processes, and manufacturing capabilities, positioning itself as a strong player within the competitive eVTOL market. In the third quarter of 2024, Archer reported a net loss of $115.3 million, with total operating expenses of $122.1 million. However, the company maintained a strong liquidity position of approximately $501.7 million in cash and cash equivalents, which is essential as it navigates the costly stages of certification and production. Archer's order book has surpassed $6 billion, driven by its partnership with Japan Airlines and a joint venture with Sumitomo Corporation, which demonstrates strong market demand for its eVTOL solutions. Additionally, Archer is seeking to raise about $400 million from Stellantis to further enhance its manufacturing capabilities for the Midnight aircraft. Achieving FAA certification is a critical milestone for Archer as it prepares for commercial operations. The company is currently progressing through Phase 3 of the FAA's four-phase type certification process for the Midnight aircraft. Following the FAA's finalization of airworthiness criteria in May 2024, Archer is optimistic about completing Phase 4 by early 2025. The company is aligning its certification efforts with the newly issued Special Federal Aviation Regulation, SFR, for powered lift aircraft, which is designed to support eVTOL commercialization in the U.S. Successful navigation of these regulatory hurdles is crucial for both Archer's operational launch and its ability to instill confidence among investors. Archer is also nearing the completion of its high-volume manufacturing facility in Covington, Georgia, set to begin operations in early 2025. This advanced manufacturing facility, which cost approximately $65 million and was constructed on time and within budget over 18 months, will significantly boost Archer's production capacity. The facility is designed to produce up to 650 aircraft annually, enabling Archer to ramp up production to 2 aircraft per month by the end of 2025, positioning the company for scalable commercial deployment. Internationally, Archer is establishing a consortium for air taxi services in the UAE and is collaborating with Japanese partners to facilitate its entry into the Asian market. These international efforts are crucial, allowing Archer to leverage existing infrastructure and regulatory frameworks, which could potentially expedite its commercialization timeline compared to domestic initiatives. Supernal LLC, a subsidiary of Hyundai Motor Group, is another key competitor in the eVTOL sector, focusing on advanced air mobility (AAM) solutions. In January 2024, Supernal unveiled the SA-2 eVTOL vehicle at CES 2024, a significant advancement from its 2020 concept, the SA-1. The SA-2 is designed as a pilot plus 4-passenger aircraft that prioritizes safety, sustainability, and passenger comfort. With an all-tilting rotor configuration, the SA-2 enhances efficiency during both vertical takeoff and horizontal flight phases. The aircraft aims for a cruising speed of 120 miles per hour and an operational range of 60 miles. Supernal plans to begin prototype testing in 2025, with commercial operations projected for 2028. The company combines Hyundai's automotive design expertise with cutting-edge aerospace engineering, ensuring that the SA-2 meets global aviation safety standards while aligning with consumer expectations for comfort and aesthetics. Supernal's strategy includes leveraging Hyundai's manufacturing expertise to scale production and using mass production techniques to manage costs while maintaining high quality. The company is also focused on developing the necessary infrastructure for advanced air mobility. This includes collaborations with aviation suppliers and government entities to address regulatory challenges and public acceptance issues. At the Farnborough International Air Show in July 2024, Supernal convened industry leaders to discuss critical issues facing advanced air mobility adoption. Additionally, Supernal has announced plans for vertiports, dedicated takeoff and landing zones for eVTOLs, which will be integrated into existing transit networks. These vertiports are designed to minimize noise and enhance urban connectivity, addressing community concerns while facilitating seamless travel. The broader outlook for Supernal is positive as the eVTOL market is expected to grow significantly, with an estimated market size reaching $1 trillion by 2040. Supernal's focus on safety, affordability, and integration into existing transportation systems will be pivotal in gaining regulatory approval and achieving public acceptance. Lilium GmbH is another leading competitor in the eVTOL market, known for its development of the Lilium jet, a groundbreaking aircraft designed for up to 6 passengers. Powered by 36 electric engines, the Lilium jet aims to revolutionize urban and regional transport. The company has made significant progress, including reaching a key milestone in August 2024, with plans for its first manned flight by late 2024. The Lilium jet is designed to cruise at 110 miles per hour, and has an estimated range of 155 miles, positioning it as a strong contender in the eVTOL industry. As of October 2024, Lilium reported a commercial order pipeline exceeding 780 aircraft, which includes over 100 firm orders and more than 600 pre-orders. This robust demand highlights Lilium's innovative approach and market potential. To further enhance its competitiveness, Lilium has entered into strategic partnerships, including a collaboration with GE Aerospace in October 2024. This partnership focuses on developing scalable flight data management solutions, integrating GE's aviation safety and data analytics expertise with Lilium's Fleet Optimizer platform, and ensuring robust safety protocols for eVTOL operations. Lilium has also partnered with Atlantic Aviation to prepare North American airport sites for Lilium jet operations, with a focus on over 100 locations in key launch markets like Florida and Southern California. These collaborations are vital for establishing the necessary infrastructure and operational readiness to support urban air mobility. Vertical Aerospace, based in Bristol, UK, is another significant competitor, innovating with its VX4 eVTOL aircraft, designed to carry 4 passengers and a pilot. The VX4 features 16 electric motors, allowing for quiet operation and 0 emissions. In 2024, Vertical Aerospace completed a critical milestone by successfully conducting untethered piloted thrust-borne flight tests, bringing it closer to certification with the UK Civil Aviation Authority, CAA. Vertical Aerospace has also introduced its proprietary battery technology, developed in collaboration with academic institutions such as Oxford University. This advanced battery system delivers 1.4 megawatts of peak power, is lightweight, and supports rapid charging, significantly boosting the performance of Vertical's flagship aircraft, the VX4. In November 2024, the company secured $50 million in funding as part of a larger $180 million agreement, bolstering its Flight Path 2030 inches strategy. This initiative aims to position Vertical as a global eVTOL leader by focusing on the VX4's development and certification processes. Vertical's business strategy includes securing over 1,500 pre-orders from prominent airlines like American Airlines and Japan Airlines, which not only validate its technology but also pave the way for commercial operations pending regulatory approvals. Sustainability is at the core of Vertical's mission, addressing the growing demand for eco-friendly transportation solutions. The VX4 offers a promising alternative to traditional air travel, capable of operating in urban environments without requiring runways and with minimal noise pollution. To achieve successful commercialization, Vertical collaborates with aerospace leaders like Honeywell and Leonardo, enhancing its technological capabilities and adhering to rigorous safety standards. Partnerships with regulatory bodies further streamline the certification process. By involving stakeholders early in development, Vertical proactively addresses safety concerns and fosters public acceptance of eVTOL services. With strong funding, innovative technology, and a commitment to sustainability, Vertical Aerospace is well-positioned to launch its VX4 into the growing eVTOL market. Similarly, Volocopter GmbH, based in Bruchsal, Germany, has established itself as a pioneer in the eVTOL industry with its focus on sustainable urban air mobility. The company's flagship aircraft, the Velocity Air Taxi, is designed for emission-free urban transportation. With 18 rotors, the Velocity achieves a cruising speed of 50 knots, approximately 93 kilometers an hour, and a range of about 35 kilometers, 22 miles, per charge. By September 2024, Volocopter had completed over 2,000 test flights, showcasing its dedication to safety and operational reliability. A standout innovation from Volocopter is its VoloIQ platform, a digital system powered by artificial intelligence and hosted on Microsoft Azure. VoloIQ enables efficient fleet management and urban integration, ensuring seamless and safe operations in complex urban environments. This technology is vital for managing the challenges of urban air mobility and optimizing the deployment of eVTOL aircraft. Volocopter is making significant strides in becoming a leader in the urban air mobility (UAM) market. The company is working toward achieving certification for its Velocity aircraft from the European Union Aviation Safety Agency (EASA) by the end of 2024. This certification is a key milestone that will enable commercial operations and establish Volocopter as a major player in the competitive electric vertical takeoff and landing (eVTOL) sector. To prepare for this milestone, Volocopter has entered an operational validation phase, during which it conducts demonstration flights and fine-tunes its systems to ensure safety and reliability. In addition to its progress with EASA, Volocopter has received approval from French authorities to operate a vertiport on the River Seine during the Paris Olympics. This accomplishment underscores Volocopter's leadership in the UAM space and demonstrates its readiness to integrate urban air taxis into existing city infrastructure. These regulatory advancements not only boost Volocopter's credibility, but also lay the groundwork for its expansion into international markets. Financially, Volocopter has raised over $600 million from prominent investors such as Mercedes-Benz Group, Sumitomo Corporation, Japan Airlines, and BlackRock. This funding is crucial for advancing the development of its eVTOL technology and scaling operations as the company nears its commercial launch. To further support its ambitious goals, Volocopter is forming partnerships with local governments and private entities to share the costs associated with building infrastructure, such as vertiports and support systems. These collaborations are essential for creating a robust and interconnected UAM ecosystem. Sustainability is a cornerstone of Volocopter's vision. Its all-electric aircraft produce zero CO2 emissions and no harmful pollutants during flight, making them a cleaner and quieter alternative to traditional helicopters and other urban transport options. By prioritizing environmental responsibility alongside safety and efficiency, Volocopter positions itself as a compelling choice for cities seeking innovative and eco-friendly mobility solutions. The company also recognizes that the successful adoption of eVTOL technology requires collaboration across multiple sectors. To this end, Volocopter has established strategic alliances with aviation industry leaders and local governments. For example, its partnership with Aéroports de Paris SA is focused on developing vertiports that seamlessly connect with existing urban transit systems. Additionally, Volocopter engages with local communities through public demonstrations to build awareness and acceptance of air mobility solutions. High-profile events, such as its planned operations during the Paris Olympics, offer opportunities to showcase its technology and generate excitement about future air taxi services. Looking ahead, Volocopter remains optimistic about launching its commercial air taxi services within the next year. The company has already secured a strong pipeline of pre-orders, including a recent order from Bristow Group for 2 Velocity aircraft, which underscores the growing demand for urban air mobility UAM solutions. With robust funding, regulatory milestones, and strategic partnerships, Volocopter is well-positioned to revolutionize urban transportation and set a benchmark for sustainable, efficient mobility. In contrast, the competitive eVTOL market has created intense pressure on companies to secure funding and stay ahead in the race for commercialization. The industry's funding landscape is evolving as early-stage investment frenzies give way to more cautious investor sentiment. Companies that failed to secure sufficient capital during the earlier investment wave now face significant challenges. With investor interest cooling, only those with proven technologies and clear business models are likely to attract the necessary financial backing. For companies like Honda, this poses a challenge in navigating a tightened funding environment while competing against better-funded and more established rivals. Beyond financial hurdles, Honda and other eVTOL developers must also address public acceptance, which is critical for the widespread adoption of this new transportation mode. Concerns about noise pollution, safety, and the practicality of integrating eVTOLs into urban infrastructure are key barriers. Honda has taken steps to mitigate these issues, such as designing smaller rotor diameters to reduce noise. However, broader efforts to educate the public and demonstrate the technology's safety and utility will be essential to gaining widespread acceptance. Honda's long-term strategy reflects its ambition to play a leading role in advanced air mobility. By validating its eVTOL designs through rigorous testing and adhering to stringent regulatory standards, Honda aims to position itself alongside industry frontrunners like Joby Aviation, Hyundai's Supernal, etc. Leveraging its reputation for quality and reliability, Honda is committed to delivering innovative solutions that align with its vision for future mobility. Thank you for watching the video to the end. If you liked it, please consider liking and subscribing to the channel to enjoy more similar content. We'd love to hear your thoughts on Honda's flying cars in the comments. Until next time.